All right, so this video is going to cover the 3.3 homework. It's not going to cover all of it, but it will do, or we will do a few questions. That way you can see some of the homework problems because obviously I won't be here. So, first off, we've got factoring by square roots, or not by square roots. We've got solving by factoring. Now, we're going to start with number 4, just because some of the rest of these I think you should be able to do. But on number 4, that's where we're going to start just so we can see it. All right. So number 4. Now, the first thing you've got to notice is there's only one term here. That is a big indication of what we are supposed to do or how we're supposed to go about this. So since there's only one x squared and there's no other x, that means we probably won't be able to factor this. What we need to do is move this 81 to the left so that we can do difference of squares. So difference of squares means you can take the square root of each number. So 16x squared, the square root of that is 4x. Then you can take the square root of this second number, which is 9. You put a minus sign in between, and that's your first factor. Then the same exact thing happens for the second factor, except we make it plus instead of minus. All right, so now this is all equal to 0. So what we can do is we can take each of these, split them up, and set them equal to 0. So 4x minus 9 equals 0. 4x plus 9 equals 0. We would end up adding 9 over, then divide by 4. So x equals 9 over 4. X would also equal, so we would do the same thing over here. I'll skip it for now just because I think we can do it. So then x will also equal negative 9 over 4. So our answer is x equals the set 9 over 4, negative 9 over 4. All right, so that one's a good example of, it's not perfectly set up for you to do difference of squares. Now, real quick, again, difference of squares is when you have two terms, one squared, one has an x squared or a variable squared, and the other one is a perfect square. So like number 3, same thing. This is the perfect setup for difference of squares. When that happens, take the square root of the first, which is x here. If there's a number in front, like on number 4, there was a 16 in front, you just take the square root of that as well. Then we bring down the minus sign, take the square root of the second term, which would be 6. That's our first factor. Our second factor is the exact same, except now it's a plus sign. And then like this one would be x equals 6, x equals negative 6. All right. So let's go to another one. The next one, let's go to number 10. Because all the simple ones I'm going to kind of keep and let you just watch the other video. But this one's a little bit more complicated. So, all right. Now, when we factor, typically we want this kind of setup. We want there to not be a number in front of x squared. If that happens, that means we can just do the product sum method. It's not too difficult. But when there's a number in front of x squared, we want to try to get rid of it and factor it out. But in this case, 5, 11, 2, there's no common factor. The only common factor would be 1, so we just have to stick with this problem. So we can use two methods. There's a method called the bottoms up method. There's a method called the grouping method. I'll do it both ways just so you can see. So if I use bottoms up, here's what I do. I take the first term, I multiply it by the last term, and I actually rewrite the problem after I've multiplied that, okay? X squared plus 11x plus 10. Now I factor this by using the product sum method. So I want two factors that give me 10, add together to give me 11. So that would be 10 and 1. So then my factors are x plus 10, x plus 1. All right. Now, what I have to do once I factored this is I have to come back and divide by whatever I multiplied at the beginning. So I divide each of these numbers by 5. Now I get x plus 2, x plus 1 over 5. And I'm going to keep this 1 over 5 as 1 over 5, and I'll tell you why. Maybe in a past video I've moved this 5 to the front, but when you're solving, which we're doing here, you don't want to move that, because here's what actually happens. If we look closer at these two numbers, x plus 2, x plus 1 over 5 equals 0. I know the answers are always going to work like this. This sign will flip. So in this case, if I took x plus 2 equal to 0, my answer is going to be x equals negative 2. So the sign flips. Same thing for this. If I wanted to figure out what x is equal to, I can just flip this sign. So x is equal to negative 1 over 5. The only time you can't do that is like on number 4. If we go back to number 4, there was a number in front of x here and here. So that's when we can't do that. But we can do that if there's no number in front of x. So like here, if we keep the 1 over 5 as 1 over 5, no number is still in front of this x, so we can just flip the sign, and that's the answer. So my answer here, two answers, would be x equals the set negative 2, negative 1 over 5. All right. So that's a difficult one because you have to do bottoms up. Now let me show you the grouping method real quick. So I'm going to redo number 10. So if you don't care about the grouping method, just who cares? Just skip it. But I'm going to do number 10 with the grouping method, which the grouping method will help you with the next part of what we do, but it's not, I mean, you can do it any way you want. If you like grouping better, do that. If you like bottoms up, do that. Doesn't really matter to me. All right. Well, let's keep this here. Let's see if when I do it another way, we get the same answer, which hopefully we do. If not, I suck. All right. So now here's the grouping method. The grouping method is this. You are going to still take, you're still going to take this number and multiply it by the last, but now you're not going to rewrite the equation with that portion. You're just going to put that over here and say, okay, that's 10. Now what you want to do is rewrite your first term and your last term, but this middle portion, you're going to try to break that apart with two factors that give me 10 when I multiply, but add to give me 11. So once again, that's 10 and 1. But now we're going to break 11x apart into 10x plus 1x, or just x. So now we're doing the same thing, we're just grouping it differently. All right, so then what we can do is group these first two terms together, then group the second two terms together. Then we're going to factor out a common factor out of each of those parentheses. So the greatest common factor, and I'll show you how it ends up working. We should end up with the same thing in each parentheses when we do this. So if we factor out the first set of parentheses, we would factor out a 5x. Then we would be left with x plus 2. And then we also have x plus 2 over here. So there's an understood 1 to be in front of this parentheses. Just remember that. Now, the parentheses that are the same, that's your first factor. The second factor comes from whatever's on the outside. So on the outside, we have 5x plus 1, and that's how you factor by grouping. Now we would take our equation, set each factor equal to 0, which the first one's easy. It's just going to be, we could just flip the sign. Since there's no number in front of x, we could just flip the sign and say negative 2. Now this portion is where you can't just flip the sign, because we would flip the sign and say minus 1, but that's not the answer. We have to actually solve this one fully, which it shouldn't be too bad, because by now we should be able to solve pretty much anything. Divide by 5, divide by 5. So x ends up being negative 1 over 5. So if you noticed, still ended up with the same answer as over here. So your job will be pretty much figure out which method you want to use. I don't care which one you use. You'll see when we get up further down the road, we're going to have to use this grouping for something else. So if you want to learn it now, it will help you then. If not, doesn't really matter. All right. So let's go to another one that's a little bit difficult, and let's see if we could do it. The only thing that you need to remember is if I want to factor, I need everything to be equal to 0, so I need to move this 15 to the left. So I'm going to subtract 15. So 8x squared minus 2x minus 15 equals 0. All right. Then I'm going to factor, but I can't factor anything out, so I have to do either bottoms up or grouping. I'll do bottoms up because that's what most people like because they notice it's easier. So x squared minus 2x minus, what would 8 times 15 be? 120. All right. Then I just need to remember if I use this method, I have to come back and divide by that 8 once I get my factors. So my factors would be, let's see, negative 120. I want to multiply to get negative 2, or I want to multiply to get negative 20 and add together to get negative 2. So that'd be negative 12 and 10. So x minus 12, x plus 10. Now this is where I come back and divide by that 8. That 8 I multiplied at the beginning. Now is where I come back and divide it. All right, so x minus, I just reduced this because I don't want to move that 8 to the front in this case. Because in this case, it'll just make my life more difficult. So that would be 3 over 2. X plus 10 over 8, we would reduce this to 5 over 4. All right. Now, since I kept no number in front of x, I can just flip the signs of these two, and that's my answer. So my answer is x equals 3 over 2 and negative 5 over 4. All right. And then we can write that in the set notation. I'll be honest, if you keep it like this, I'll probably be okay with it. All right, then let's do one more. So when we get down here, I hate that I'm not there to tell you this, but there's going to be a problem like this on the final, which I'll show you a bit more in depth when we get closer to that point. But when it says identify the roots of this equation, notice that this is f of x. So that means this is a function, which means we could graph this, which we're not going to graph it, but we could. What you can actually find is the x-intercept and the y-intercept. When it describes roots, it's saying what is the x-intercept. It's essentially saying solve this for x. And this is a quadratic, which in this case, it's pretty easy. It's already set up. So the problem I want you to see is like 15 where you have to factor this, but really one like number 18. Number 18 is the hardest one because you have to remember a few different things. First of all, this is a quadratic, which means we need to solve for x to find the x-intercept or the roots. Now, to do that, we have to simplify this first, which means we need to multiply this, not multiply, but apply that exponent of 2 to the x minus 2, which once again, everyone does this, not everyone, but a lot of you do this wrong. This is not just x squared. This is not just x squared plus 4, okay? We have to either FOIL this out like this. So we have to say x minus 2 times x minus 2, or you can use the trick I've shown you before, which I'll show you that one again. But if we do that here, we would get x squared minus 2x, and then plus 4, which would end up simplifying to negative x squared minus 4x plus 4. And then we would have another plus 4 on the end. All right, now let me show you the trick one more time so you can see it. If you have a parentheses squared, here's what you can do. You can take x minus 2 squared, and you can square the first term which is x squared. You can square the second term, which would give us plus 4. Leave a space in the middle, and then you take 2 times x times 4. Or it would actually be negative 2. So you take your first term times the second times 2. And this would give us minus 4x, which is exactly what we ended up with over here. So either way you do it, you either have to FOIL it or use this method. I don't care. Either way. All right. So now we have to do this. We need to distribute this negative. So this would be negative x squared plus 4x minus 4. And then it would not go all the way over here because that's not connected. So this would actually be plus 4. Now you'll notice when we do that, negative 4 plus 4 is 0. So that cancels. So we have negative x squared plus 4x. And this is acting like, to find the roots, we're going to say f of x here, but it's really like saying 0 here. So we're still going to solve this the exact same way. All right. So now we need to factor this, and we can factor this with a GCF. We could actually just take out, we could factor out a negative x, and we'd be left with x minus 4. So then this and this get set equal to 0, and you'll see actually turns out pretty easy. Negative x equals 0. That means x just equals 0. X minus 4, since there's no number in front of that x, once again, you don't even have to write that out. You can just flip this sign, and x equals negative 4. So these are the answers, which if we were writing it out technically correct, it would be 0, negative 4. All right, so hopefully that answers any questions you have. Any other questions you can just save or help each other out, but that's going to be it for this video.